The protection of water bodies in Europe is regulated by the Water Framework Directive, WFD, which is mandatory for all European Union members. Detecting and monitoring the level of contaminants in water bodies is a key element of the WFD. In many cases, it is very difficult to respond to WFD demands for the assessment of chemical status of waters. Why? Because conventional sampling techniques based on spot sampling present several disadvantages such as lack of representativeness and analytical difficulties. However, these disadvantages can be overcome by the use of passive sampling methods. The main barrier hindering the regulatory acceptance of passive sampling for compliance is the lack of appropriate environmental quality standards, EQS. EQSs for metals are defined based on the dissolved metal fraction, therefore preventing the use of passive sampling in a regulatory context, as this captures labile concentrations. What is MONITOOL? MONITOOL is a European project whose objective is to adapt existing metal water environmental quality standards, EQSs, for passive sampling devices, PSDs, thus allowing their use to evaluate the chemical status of waters under the WFD. The passive samplers devices used in MONITOOL are the DGT. But what is DGT? DGT stands for diffusive gradient in thin films. A DGT is a passive sampler that is deployed directly in waters for about 5 days, allowing the labile metals to accumulate onto the Chelex 100 gel layer of the device during the entire deployment period. To fulfill this ambitious objective, a successful campaign for DGT sampling and analysis in coastal and transitional waters was conducted over 2 periods across the Atlantic and Mediterranean region, covering a variety of environmental conditions. Protocols for spot water sampling and co-deployment of DGTs and for sample processing were produced. Common guidelines were followed by all partners to ensure the comparability and reproducibility of data obtained in different partner regions. Additionally, participating partners also took part in the DGT interlaboratory exercise organized by Inframer for the development of a DGT expert lab. Laboratory analysis results have provided us a robust MONITOOL dataset. Based on these data, the relationships between the dissolved labile metal concentrations measured in the DGT-type passive sampling devices and in discrete water samples collected during the DGT deployment time have been investigated. While strong log-log linear relationships between DGT sampling and spot sampling have been observed for cadmium, manganese and copper, medium relationships have been observed for nickel and lead, and weak relationships for zinc and cobalt. DGT sampling spot sampling ratios were shown to be independent of broad-scale environmental variables such as pH, temperature, salinity, dissolved oxygen, dissolved organic carbon, and suspended particulate matter, as well as of sampling season, winter or summer. Complying with the stated objectives and based on MONITOOL database, after a thorough statistical process and using a pragmatic approach, it has been possible to adapt the existing metal water environmental quality standards, EQS, for these passive sampling devices. Thus, DGT EQSs have been proposed for cadmium, nickel and lead, as well as for the other metal ions that were studied. Much work has also been done in the interpretation of DGT results and in investigating the possibility of predicting the metal concentration in the dissolved fraction from the DGT results, specifically for cadmium, nickel and lead, and comparing these predicted concentrations to the existing marine water EQSs. In addition, a simulation on chemical status assessment has been done in order to identify the existence of differences between the chemical status assessment level based on dissolved metal concentrations in spot water samples and DGT results obtained during MONITOOL campaigns. This is the first broad geographical scale study using the DDT technique in different marine regions, covering a variety of environmental conditions across the Atlantic and Mediterranean regions. Based on the results obtained in this project, it can be concluded that the DDTs may improve the quality of the overall assessment in dynamic marine waters to comply with the Water Framework Directive and the Marine Strategy Framework Directive, since this methodology can provide time-weighted average concentrations integrated over the period of deployment. This allows a better assessment of the sampling sites in terms of spatial comparison and their evolution over time. MONITOOL, new tools for water quality monitoring.